Hello, ladies and gentlemen. I hope you're all doing well and you're ready for question number 4 on our 2012 Euclid paper. Right. So we've got two light bulb parts here. Or, sorry, not two light bulb parts. We have two parts. First one with the light bulb, second one requiring full solutions. The horizontal line, y equals k, intersects the parabola with equation y equals 2x minus 3 times x minus 5, so I can clearly tell the roots, at points A and B. If the length of line segment AB is 6, what is the value of k? Okay, so picture-wise, what have we got? Well, we've got sort of an upward-facing parabola that passes through 3 and 4 on the x-axis. And you multiply it by 2, so it's probably a little steeper than you usually used to. Move 5 over here. And so we've got a line coming across y equals k. And we've got AB, and we know this should be 6. Okay. So how can we work out what this question should be? Or, sorry, what the answer to this question should be? Well, we know the roots, and there's another nice thing to know about parabolas. They are symmetric along the line that sort of goes right down the middle, right through the vertex. Okay? And so everything's nice, neat, and symmetrical. And so the roots here, at the same height, they both have a y-coordinate of 0. They're the same distance away from this axis. And since the distance between 3 and 5 is 2, this should be 1, and so this axis here is x equals 4. Now, how does this help us with A and B? Well, the distance between A and B, because they're at the same height, is going to be the same distance from A to the axis as it is for B. And since we know the total length of AB, we see each of these is 3. And so we can actually work out the x-coordinate for A and the x-coordinate for B if we wanted it. Okay? We know the middle runs right through x equals 4, so 3 to the left of that would be at 1. 3 to the right of that would be 7. And now we know the equation for the parabola, so we can work out this height, and that gets us the value of k. Okay? So, y equals 2, 1 minus 3, 1 minus 5. That'll be 2 times negative 2 times negative 4, and that'll be 16. So k equals 16. And so it's a light bulb question. We really just needed that, but we managed to show a little work using this nice symmetry for parabolas. Okay, so that helps us quite a bit. All right, looking back now at 4b, which we actually do need to write up. Determine 3 pairs, A, B, of positive integers for which, this big expression here is a perfect square. Now they're saying determine 3 pairs. They're not saying something like determine all pairs or show that there's only 3 pairs. They're telling us there are 3 answers. Okay? So if we find 3 ABs that work, we go with it. We absolutely do. We don't have to worry about all the other possibilities or anything like that. So we've got a lot of A's, a lot of B's here. Let's just write this expression down. 3A, 6A, 9A, 12A, and 15A, I believe was what I saw there. And then looks like the coefficients in front of the B's are twice that in front of the A's. So we get 6, 12, 18, 24, and 30. What can we do? Well, I don't really see why these are separated into A's and B's other than to make the question ever so slightly longer to do. 3A plus 6A is 9, plus another 9A is 18, plus 12 is 30, 45 A's. And over here, we'll add up and we'll get 90. 90 B's. So we could take out a factor of 45. Okay? And so now my perfect square needs to be 45 times A plus B. And I can actually pick lots of different A's and B's to make this almost anything that I want. And we want it to be a perfect square. Well, 45 already has a factor of 9. And that's a perfect square. So we just need to make 5 times A plus 2B a perfect square. Gotta make that a perfect square. So what can we do? Well, we need an extra factor of 5 in here to pair up with this 5. We need 2 factors of 5 to get a perfect square there. So what we'd like is, so we need a plus 2b to be 5 times a perfect square. Okay, well, let's just pick a few perfect squares, or we could be, silly about it. But if k is 1, we need a plus 2b to be 5, so we could say let a be 1 and b be 2. If k was 2, then this expression is 20. Okay, let a be 2 and b be 9. That works. And for 3, we'll get 9 times 5. We need a plus 2b to be 45. Okay, and we can do that. Let b be 22 and a be 1. Right, that should work. We needed, positive integers. We've got them. They didn't have to be distinct, but they were. Okay, so AB equals 1, 2. What was the 2, 9, and 122 will work. We don't need all the ABs, we just needed 3 of them. So this was more a question of simplifying the expressions. That was probably a mark. Taking out the 45, realizing you needed the extra factor of 5, and then probably a mark for each correct one. Something like that, I imagine. Okay. So there we go. That was question number 4. Up next, question number 5. I'll see you for that in the next video.